Breaking the wall of damage-free microscopy. Carina Kanitz. Falling Walls Lab, Baden-Württemberg.
Imagine you are a scientist, a material scientist, working in a lab, working on the pressing problems of our time, maybe creating a more sustainable filter for clean water. And after days, months, maybe years in the lab, you have come up with a promising new material. You take it to a microscope to investigate it. And while looking at it, it disappears right in front of your eyes. What happened? In order to image, to see something, we need light, a wave. And the size of the light, the wavelength, has to match the size of the object we want to have a look at. This becomes very challenging when we want to have a look at atoms, for instance, because optical light is just way too big for that. Or have you ever seen an atom? So what do scientists do instead? They use the wave nature of electrons, because those have the handy feature that they get smaller when we make them faster. So we just use super fast electrons to image materials. But this is also what destroys our materials. So what can we do? So instead of taking those super fast electrons, we can replace them by slower, more gentle atoms. They have the same wavelength at much lower energies, and additionally, they are not charged. This is an advantage because they are more gentle to the material, but also a disadvantage because it makes them incredibly hard to manipulate and control. Probably this is one of the reasons why no one has done transmission atom microscopy so far, or until very recently. Because during my PhD, I built up this beamline from scratch that does exactly that, using atoms as a light source to shine through a material, a crystal, and to image it on the atomic scale for months without damaging it. Additionally, I can not only study the structure of the material, but by comparing to simulations, I can also get a glimpse into the chemistry of the material, how the atoms are bound together. So now imagine you're a material scientist studying new materials, and you can look at your sample for months on end. This saves you a lot of time, a lot of resources, and you produce much less waste by using the same sample over and over and over, and maybe even seeing how the sample changes while you look at it and maybe swap out a tiny atom and see how the chemistry is changing. So, by using atoms as a light source, I am breaking the wall of damage-free microscopy.